this question, the question state is, it is regarding the circular motion basically. So a flat plank of the mass m is revolving in a circular circle of the frictionless air hockey table, okay, toe, as it is hold on the orbit of the mass of this one of the massless plank, okay, and which is connected to the dangling mass. So there is a mass that is attached to this string basically, you can think like this, and through the central hole as shown in the figure. Show that what the speed of that. So you have to show what is the speed of this one that is revolving around that. So basically that you have to keep in the mind what is the force, what the force that is acting toward the center. So right now the force that is acting toward the center, so that is due to the, you can say that the uh, tension force that is going to be act toward that one ft, let me call it the tension force that is acting toward the uh, center of that one. And if you can see it carefully, because it is attached to this mass, so on this mass you have the mg force that is acting it downward. So this is mg force that is acting it downward here. So small mg, and so because it is revolving, you can think like this, it is not falling down basically, it is not falling down. So you can simply say that if it is not falling down, whatever the tension force at this point, if you look at this tension force that is acting it upward, that have to be equal to the mg force that is acting it downward. So I can mention like this. So the tension force ft is equal to mg force if the block is not moving downward. So they are mentioning that one, the complete the dashing motion through the central hole or something. So this is the F tension, and the tension force that is acting toward the center, the force that act toward the center, we call it Ft is, this is the direction is toward the center. This force we call it the centripetal force, simple centripetal force that is providing that one. So, and as we know that the centripetal force Fc, I mean to say that centripetal force, the formula is for that one is capital M. In this case, you have to take it capital M, the object that is revolving, that is capital M that they given, and the speed that we have to find it out, ha, mv square by r is the radius of it. So when it is going to be moved, it, if it is going to be provided centripetal acceleration, due to that it is not going to be fall down even this mg force. So the point is, so when it is going to be revolved, so who is going to provide the centripetal force here? That is going to be provided by the tension force, and the tension force is equal to mg in this case. Mg is equal to capital mv square by r. And so as you shuffle that one, if you rearrange that, mg capital R go to this side, and capital M goes to the denominator, this is v square. And that simply the v is, if you rearrange it, come out to v square root of that, and how simple that one is. So, and you go to your answer. So hopefully you understood it. So watch it again, comment it. Bye bye.